Hi everyone, once again welcome back to our channel. Today going to discuss about the Poisson ratio, compressibility, the density of compressed liquid and some etc. problems with problems. First of all, discuss about the compressibility. What is the compressibility? The statement of compressibility here. According to here, we know that bulk modulus. The bulk modulus B is equal to minus delta P by delta V by V. This is the formula of bulk modulus of the fluid or solids or gases. Now, compressibility means the reciprocal of the bulk modulus is called as here compressibility. It is denoted by K. It is denoted by the K. After we will discuss about the density of compressed liquid and Poisson ratio, the relations volume strain, lateral strain and Poisson ratio, etc. First of all, we will discuss about the here compressibility. The compressibility means the reciprocal of the bulk modulus is called as here compressibility. So, statement here, note this one. First of all, the reciprocal of the of bulk modulus is called compressibility. Is called here compressibility. It is denoted by here K. It is here denoted by K. That means the compressibility K is equal to here K is equal to the reciprocal of here bulk modulus. Reciprocal of here bulk modulus. Okay, bulk modulus. That means here K is equal to just reciprocal. So K is equal direct proportional to here B. Direct proportional to here B. So the bulk modulus of the fluid or liquid or solids here B is equal to stress by bulk strain, that is equal to delta minus delta P by delta V by V. This is a bulk modulus. Now here K is equal to the reciprocal, just reverse here, that means delta V by V 1 by delta P, 1 by here delta P. This is a formula of compressibility. So here the compressibility of dimensions and units and here dimensions. Now that is equal to just K between direct proportional, remove the direct proportional any, K is equal to, for example, 1. So K is equal to delta V by V, that means into 1 by delta P. This is a volume strain. This is a volume stress. This one here volume strain. So SI units of this one Newton inverse and meter square. The dimensional formula dimensional formula here. This one M, capital M, inverse L, T inverse 2. This is a dimensional formula of the compressibility. This is a dimensional formula of the compressibility. Now, the compressibility here, the solids and ideal liquids is a are in compressibilities. That means here the bulk modulus of the fluids, solids and liquids is equal to infinite. That is here, for example, K is equal to 0 in compressible solids and ideal liquids. So K is equal to 0. That is equal to beta is equal to here B. K is equal to 1 by B. Here K is equal to 0. So here B is equal to infinite. B is equal to here infinite. This is a compressibility of the fluids. Now next we will discuss about the density of compressed liquid. Density of compressed liquid. Actually the pressure is increases, the volume is the volume of the liquids or gas or solids decreasing, the density is increasing. So pressure increases, at the same time the volume is decreases, the density, its density is increases. So here in this process the mass of the liquid or solids or gases is constant. Now note this one. First of all, here density of compressed liquid. If here compressed liquid. Now if so the liquid of mass B, for example, if a liquid of mass here M and volume V, then here its density is here rho. For example, here density is rho. So the volume is, pressure is increased, the pressure is here increased, the volume is here decreased. At the same time the density is increased, So మనం పీడనం పెంచినట్టయితే దాని యొక్క ఘన పరిమాణం తగ్గుతుంది, అదే సమయంలో దాని యొక్క డెన్సిటీ ఇంక్రీజ్ అవుతుంది. ఇన్ దిస్ కేస్ ద మాస్ ఈజ్ కాన్స్టెంట్. హియర్ మాస్ ఈజ్ హియర్ కాన్స్టెంట్. సో అకార్డింగ్ టు డెన్సిటీ ఫార్ములా, హియర్ డెన్సిటీ ఈజ్ ఈక్వల్ టు డెన్సిటీ rho is equal to here mass per volume. Mass for this is a liquid, for a volume of the liquid, mass of the liquid here, density of the liquid. That means here simplifies rho is equal to mass by V. Here mass is constant. So the density of the fluid is inversely proportional to the volume of the liquid. So here M constant. Here M is constant. Then here P directly proportional to, inversely proportional to 1 by V. Simplifies rho V is equal to constant. Rho V is equal to here constant. This equation partial differentiating on both sides. Here the bulk modulus of this liquid here, this here liquid K, for example K, compressibility K and bulk modulus here B. Compressibility K and B means here bulk modulus of the given liquid. Now P rho directly inversely proportional to 1 by V, rho V is equal to constant. Yeah, so this equation differentiating on both sides. Now that is here P rho V is equal to constant. So differentiating on both sides. Now this is equal to here rho delta V plus here V delta rho is equal to 0. So simplifies rho delta V is equal to minus V delta rho. So simplifies this equation delta V by minus delta V by V is equal to here delta rho by here rho, delta rho by rho. This is equation 1. This is equation 1. ఈ ఈక్వేషన్ అంటే మనకి మైనస్ డెల్టా వి బై వి ఈజ్ ఈక్వల్ టు డెల్టా రో బై రో. డెల్టా రో మీన్స్ చేంజ్ ఇన్ density. Here V means delta V means change in volume. So the volume is here decreasing. So negative symbol indicates the volume is decreasing with increase of the pressure. Now this is the equation 1. But here we know here bulk modulus here B is equal to minus delta P by here delta V by E V. This is according to bulk modulus formula. The definition of the bulk modulus B is equal to minus delta P by delta V by V. So this one here delta V by V is equal to minus delta V by V is equal to delta P by B, delta P by B. This is the equation 2. This one here equation 2. Okay, this is the equation 2. According to bulk modulus, the change in volume by original volume, that is equal to change in pressure by bulk modulus. So delta minus delta V by V is equal to delta P by B from equation 192. So from equation 192, note this one. Then note this one. Now this equation and here this two equations. Okay, from equation 192. Here from equation 1 and 2. From equation 1 and 2. After we will get the change in density of liquid after compression. Okay. Now equation 1 here, equation 1 delta V by V is equal to delta rho by rho. This is the equation 1. Yeah, this is the equation 1. And equation 2 delta V by V is equal to delta P by here B. This is the equation 2. These two equations. So from 192, from here from 1 and 2. 192. After we will get here equation compared to these two equations. Delta rho by rho is equal to here delta P by B. Delta P by B. So this is a change in density. So simplifies rho prime minus rho by rho is equal to delta P by here B. Delta P by B. But this is a simplifying rho prime minus here rho is equal to rho delta P by B. Rho means density of the fluid or liquid given liquid. P means delta P change in pressure. This is a B means here bulk modulus. Now this is the taken right side. The rho is here taken here right side. Rho prime is equal to here rho plus rho delta P by here B. Delta B. Now here P is common terms. Here P is a common term. Simplifies here rho prime is equal to rho into 1 plus here delta P by B. So finally the density of the fluid after compressed delta rho prime is equal to here rho into 1 plus here C delta P. Here C means constant. Here C is a constant. This constant is a compressibility. This is a constant is a compressibility. So here C is equal to here C is equal to 1 by B. That means here compressibility. Okay, this is a compressibility. The relation between here delta P means pressure, change in pressure. C compressibility of the given liquid. So density of the initial density of the fluid, and this is the final density of the fluid or liquid, given liquid. So this is the equation of the density of compressed liquid, the density of compressed liquid equation here, that is equal to rho prime is equal to rho into 1 plus C delta V. This is the equation. After, now we will get, for example, when a rubber ball, when a rubber, for example problem based on the this formula. For example, here this is a here fluid or liquid. This is a liquid or water. This liquid means nothing but here water. When a rubber ball of volume V, its here its bulk modulus, yes, its bulk modulus here K is taken into a depth to H in a water. Then the decrease of volume of the ball, ఇక్కడ ఏంటంటే ఒక నీటిలో ఒక రబ్బర్ బంతిని ఇనిషియల్ వాల్యూమ్ V, ఈ బంతిని డి లోపలికి తీసుకుపోయినట్టయితే ఆ డి లోపల దానిపైన కాస్త ప్రెజర్ యాక్ట్ అవుతుంది. అప్పుడు ఆ ప్రెజర్ యాక్టివ్ వల్ల బికాస్ ఆఫ్ దిస్ ప్రెజర్ ద వాల్యూమ్ ఈజ్ డిక్రీజింగ్. ఫైండ్ ద వాల్యూమ్ ఆఫ్ ద బాల్ ఇన్సైడ్ ఆఫ్ ద water, okay, note this one. Yeah, note this one. Next example problem, when a rubber ball, question what rasas ne simply, yeah, when a rubber ball of volume V and bulk modulus here K is taken to a depth means lotu, depth, okay, depth in a depth here H, for example depth in a H, the lotu entam ikkada H in a water, okay. Then the decrease of its volume, then decrease of its volume, okay. Question mark enta the decrease of volume is here, initially, first of all, the bulk modulus of this water, this is a water, for example water, okay. So initially the volume of the ball here, this is a, for example ball, the initial volume of the ball here V, this ball taken inside of the water here, depth here H. So this is taken, this point taken inside of the here water, here IT here, this is a depth means here H. Now initial volume V, your final volume here dV, find out the final volume of the rubber ball inside of the water in depth D, okay, depth here H. So PA means atmosphere at surface of the water, so the next the pressure inside of the water here PA plus here P delta P here, delta P. So the pressure is increased going to inside of the depth, అంటే లోతు పోయిన కొద్ది మనకి ఏమవుతుందంటే డెప్త్ అనేది ప్రెజర్ ఇంక్రీజ్ అవుతుంది. సో దిస్ ఇస్ PA మీన్స్ అట్మాస్ఫియర్ ప్రెజర్, అప్పర్ సర్ఫేస్ ఆఫ్ ద ఫ్లూయిడ్. PA plus DP, here pressure increased in the water. So here delta P means change in increased pressure. So here delta P is equal to Hg here rho, Hg rho. Delta P means here Hg rho, change in pressure. This is a change in pressure. H means depth of the this water, d g acceleration due to gravity, and rho means the density of the water. Now we find out the decrease of the rubber ball inside of the water. So now first of all, delta P is equal to H, G and rho. This is a change in pressure. But bulk modulus here, here K. It is a bulk modulus taken here K, here in K. So K is equal to minus delta P by here delta V by V. So we find out the delta V. So simplifies this equation here, minus delta P by is equal to K into delta V by V. Here minus symbol indicates, the negative sign indicates the volume is decrease with increase of pressure. So simplifies, so P is equal to delta P, that is equal to here rho G H, here rho G H is equal to K delta V by V. Simplifies here rho G H V is equal to by K is equal to here delta V. This is a delta V. We want find out the volume of the ball inside of the water. Depth here H ante ఎత్తు లోపల H లోతు లోపల రబ్బర్ బాల్ యొక్క వాల్యూమ్ తీసుకున్నట్టయితే మన ఫార్ములా ఏంటిది, డెల్టా V is equal to rho G H V by K. This is a bulk modulus. K is a bulk modulus inside of the water. So rho means density of the water, G acceleration due to gravity, and H the depth of the water, V means initial volume of the rubber ball. Next we will go to discuss about the Poisson ratio and lateral strain, volume strain, the relation between volume strain, lateral strain, Poisson ratio. Okay, now note this one here first of all. Okay, this is an equation, important formulas. Now Poisson ratio. Okay, Poisson ratio. Here Poisson's ratio. Okay, Poisson ratio. First of all, here the wire, the length of the wire L, the radius of the wire R, diameter of the wire here D. This wire subjected to stress or force or load, then the length is increased. At the same time, its diameter or the radius is decreasing. Now here first of all, here this is a rigid support. For example, this one here rigid support. Initially the length of the wire here, for example, this is a wire, this one here wire. Okay, this is a wire. Initially the area of the cross section A, Young's modulus here Y, the length of this rod here L, length of this rod here, the diameter of this rod here D, radius R initially. Now after some loaded other end of this wire, then this wire elongation, this wire here elongation produced in the wire. At the same time, the diameter is decreased. The diameter is here decreased. So this one here after loaded this wire, after loaded this wire, okay, after loaded this wire, after here loaded this wire, okay. First ఎలా ఉంది, this is a initial after loaded. This is the diameter D. The diameter here D minus delta D, or radius here R minus delta R, R minus delta R. The length of the, now after load, the after load or applied force or load, one end of the this wire. This force acting perpendicular to the area of the cross section of this wire. Now the length is increased. The length is here L plus here delta L, L plus here delta L. Okay. Initial length L after loaded. Okay. Final length here L plus delta L. Initial diameter here D, after diameter D minus delta D. The initial radius or after loaded, the radius here R minus delta R. That means here ఈ లోడ్ చేసిన తర్వాత ఏమవుతుందంటే the elongation is increased, the elongation is increased, its diameter of the wire and radius of the wire decreases at the same time. So here two strains produced in the wire, two strain produced at the same time, two strains produced in this wire. One is lateral strain, another one is here longitudinal strain. One is here lateral strain and another one is here longitudinal strain. So first of all, longitudinal strain. Here two strains are produced in the wire. Two strains. First of all, lateral strain. Okay. Lateral strain. Lateral strain means the change in the ratio between change in radius or diameter to original diameter or radius is called as here lateral strain, is called as here lateral strain. So lateral strain statement, the ratio between original change in the radius or here diameter to your original initial or original radius or diameter. Okay, diameter is called here lateral strain. See, lateral strain. So that is here, that is lateral strain is equal to, lateral strain is equal to, so change in radius or diameter, here change in a diameter or radius, just radius. Okay, radius by original radius, here original radius, here change in radius means this is a change in delta R means here change in radius, delta R means here change in radius, here R means original radius of the given wire. So here lateral strain is equal to, simplifies lateral strain is equal to change in radius means here delta R, minus symbol పెడుతుంది ఇక్కడ, here minus delta R by original radius here R, R. This is a lateral strain, here lateral strain. So lateral strain is equal to minus delta R by R. Here R means minus symbol indicates the diameter is construct, the diameter is a construct under the stress, అంటే వెయిట్ ఎక్కువైనట్టయితే ఆటోమేటిక్గా దాని యొక్క డయామీటర్ అనేది లేదా రేడియస్ అనేది డిక్రీజ్ అవుతుంది. యాజ్ వెల్ యాజ్ ఇట్స్ లెంత్ ఈజ్ ఆల్సో ఇంక్రీజెస్, హియర్ లెంత్ ఈజ్ ఆల్సో హియర్ increase. So this is a lateral strain is equal to minus delta R by R. Next, in this process, produce a longitudinal strain. Here initial length L, here final length L plus delta L. So change in length here delta L. Change in length here delta L. So longitudinal strain is statement here the ratio between change in length to original length of the wire. This is called as here longitudinal strain. So longitudinal. Next one, longitudinal strain is equal to change in length to length by original length. Original length. That means the longitudinal strain is equal to, that means here that is equal to longitudinal strain is equal to change in length means here delta R. Here change in delta R means here change in length. Here original length means here L. So delta L by L. This is a change in length by original length. That is equal to longitudinal strain. In this process, the longitudinal strain is equal to, or the lateral strain is equal to directly proportional to longitudinal strain. The lateral strain is directly proportional to longitudinal strain. So note this one, continuation. Important points, main points for using NEET and JEE Mains. Here lateral strain is directly proportional to longitudinal strain. Now point here, lateral strain is directly proportional to longitudinal strain. Longitudinal strain. Okay, that means here that means lateral strain directly proportional to longitudinal strain. Okay, this is a ratio directly proportional. The longitudinal strain, lateral strain is directly proportional longitudinal strain. So remove from the directly proportional from this equation. Now longitudinal strain is equal to here lateral strain is equal to any constant, given any constant, into longitudinal strain. Longitudinal, okay, strain. This is a rho, sigma is a constant. Here sigma is a constant. This called as here Poisson ratio. Sigma is a here Poisson ratio. So Poisson ratio, this is a here sigma means Poisson ratio. Here Poisson ratio. This ratio means the Poisson ratio is a ratio of two strains. The two strains here, lateral strain and longitudinal strain. Now, so Poisson ratio, sigma is a Poisson ratio. So this is it is a ratio of two strains. So the Poisson ratio is equal to Poisson's ratio is equal to lateral strain by longitudinal strain. Okay, longitudinal strain. that is equal to lateral strain means minus delta R by R, minus here minus delta R by R. This is a lateral strain by longitudinal strain delta L by change in length by here original length. This is a Poisson ratio. Okay. So Poisson ratio is a numerical number. It is a so it has no units and dimensions. The Poisson ratio has no units and dimensions. So the Poisson ratio only depends on the nature of the material. So the Poisson ratio values, theoretical values minus 1 to 0.5 and practical values 0 to 0.5. In generally the Poisson ratio value of the Poisson ratio 0 to 2 to 0.4. These points, main points, note this one here. It is a ratio two strains of strains. It is a ratio of two strains. Okay, note this one here. Next, the Poisson ratio is a numerical. Two key points రాసుకోండి here, 2 or 3 points. It has no units and dimensions. The Poisson ratio, first point, it has no units and dimensions. Okay, it has no units and dimensions. Next point, theoretical values. Theoretical values here minus 1 to 0.5. Theoretical values here minus 1 to 0.5. Next, practical values. Practical values here 0 to 0.5. In generally, the Poisson ratio change in between. In generally, third point రాసుకోండి ఇక్కడ. In general, the here Poisson values in general here, the Poisson ratio values here 0.2 to 0.4. 0.2 to 0.4. These main points, these are here 3 main points. Okay, it has units and dimensions. Theoretical values minus 1 to 0.5, practical values 0 to 0.5, and in generally the values ratio Poisson ratio in between 0.2 to 0.4. This is a Poisson ratio. Now the relation between, next one, note this one. Note this one, the relation between volume strain, lateral strain and Poisson ratio Okay, the relation between, now the relation between here, relation among the relation between the relation among volume strain comma lateral strain and here and Poisson ratio, Poisson's ratio. Okay, Poisson ratio. Here 3 values ఉన్నాయి. Volume strain means delta V by V, lateral strain means delta R by R, and the Poisson ratio is a sigma. So sigma is equal to minus delta r by delta L by L. Now first of all, the length of the given wire, the length of the wire here L, the length of the wire here L. Area of the cross section A, the volume of the wire here V. Volume of the wire here, for example, this is a rigid support, okay, rigid support. This is area of the wire A, okay, length of the wire here L, volume of the wire here V, volume of the wire here V. Now this one, the volume of the this wire, so volume of wire V is equal to here 4 by 3 5 r square here. So area of the cross section of here A is equal to 5 r square, okay, area of the cross section of the wire here 5 r square. The length of the wire here L, the volume of this wire here equal to A L, that is equal to 5 r square L. This is the volume of the wire. This equation, first of all, and logarithm on both sides. After that, partial differentiating with respect to partial differentiation on both sides of this equation. Okay. After we will get here, first of all, this V is equal to 5 r square L. So V is equal to 5 r square L. This one here, logarithmic and partial differentiation. After we will get here delta V by V is equal to here 2 delta R by R place here delta L by L. This is one logarithmic. After that, partial differentiation. After we will get to delta V by 2 delta R by R plus delta L by L. Delta L by L means here the longitudinal strain, and delta R by R here lateral strain. This one delta V by V means here volume strain. Now this is the equation 1. Now the relation between here volume strain and lateral strain and Poisson ratio. Lateral strain means here delta R by R. The relation among volume strain, Poisson ratio and lateral strain. So delta V by V is equal to 2 delta R by R plus delta L by L. This is a longitudinal strain, the delta R by R according to Poisson ratio. So Poisson's ratio here sigma is equal to minus delta R by R by delta L by L. This is the ratio between lateral strain to longitudinal strain. So lateral strain is equal to, so simplifies here, this is a delta R by R is equal to cross multiplication, this one here cross multiplication minus sigma here delta L by L. This is here delta R by R is equal to minus sigma into delta L by L. So this equation 1, this is equation 1, here this equation 2, this one here equation 2 substituting in equation 1, అంటే రెండవ సమీకరణాన్ని ఒకటిలో ప్రతిక్షేపించగా from 1 and 2. After we will get here, we will get delta V by V. Delta V means change in lateral volume strain. So volume strain delta V by V is equal to 2 into here delta R by R. Delta R by R is equal to minus sigma into here delta L by L into place here delta L by L. So plus into minus. So here common terms simplifies one step. Delta V by V is equal to here delta L by L minus 2 sigma here delta L by L. In this equation, here common term delta L by L. So this delta L by L longitudinal strain is taken as common, taken from, so delta V by V volume strain is equal to so delta L by L into remaining terms 1 minus 2 sigma. This is the relation between the relations among volume strain, lateral strain, longitudinal strain, and here sigma means here Poisson ratio. This is the main formula. Okay, note this one. For example, one problem cheyandi. Note this one. Here a wire, a 3 centimeter wire, copper wire is stretched. For example, here example problem. 3 centimeter wire is stretched, copper wire is stretched. In increase of the wire is 0.3 centimeters. For example, 0.3 centimeters. Find the here lateral strain or Poisson ratio. Find the here, for example, Suddham Poisson ratio. Find out the lateral strain. For example, here this is a wire, this one here wire. Initially this wire here 3 centimeters. This wire is stretched. This wire is here stretched. So the elongation produced in the wire is 0.3 centimeters. 0.3 here 3 centimeters. This is a this one here change in length. This wire is stretched. After the Poisson ratio of this wire here 0.26. Poisson ratio of this wire is 0.26. Find out the lateral strain of this wire. Ante ee wire yokka initial podavu entamma 3 centimeters. After this is a copper wire. This copper stretched along the elongation of in this wire here 0.3 centimeters. Okay, 0.3 centimeters. This is delta L. Now the Poisson ratio of the copper wire is here sigma is equal to 0.26. Find the here delta L is equal to 0.3 centimeters. The length of the initial length of the wire here 3 centimeter. The Poisson's ratio of copper here, for example, copper wire is here sigma is equal to 0.26. It's a numerical number, so there is no units and damage. Find the lateral strain of the wire. Lateral strain of copper wire. Okay, copper wire. Okay, first of all, statement, the Poisson ratio statement here. First of all, formula of the Poisson ratio. So Poisson's ratio is equal to lateral strain by here longitudinal strain. Okay, this is a formula. So the longitudinal strain, first of all, the longitudinal strain of the wire for here, first of all, here longitudinal strain is equal to here delta L by L. So change in length by original length of the wire, copper wire. So change in length means here 0.3 centimeters. Original length here 3 centimeters. That means here simply 0.3 by 3. That is equal to here 0.1 centimeter. 0. It is no units. It is no units. Now the lateral strain is equal to Poisson ratio into just longitudinal strain. So lateral strain is equal to lateral strain is equal to Poisson ratio into here longitudinal strain, longitudinal delta L by L. That means here sigma is equal to sigma nothing but here Poisson ratio of the copper wire 0.26. Okay, so 0. Delta R by R. This is equal to the lateral strain. That is equal to here lateral strain is equal to 0.26 into and longitudinal strain of the copper wire is equal to 0.1. 0.1. Now into 0.1. So 1, 2, 3. That is equal to 0. How many digits? Total 0.026. This is a there is no units and dimensions of the lateral strain. There is no units and dimension of the lateral strain. This is a lateral strain of the given copper wire. This is a class. Next class continues చేద్దాం. ఛానల్ని సబ్స్క్రైబ్ చేయండి, చూడండి, ఫ్రెండ్స్ కూడా షేర్ చేసుకోండి. ఓకే, ఆల్ ది బెస్ట్ ఫ్రెండ్స్. థ్యాంక్ యూ.